What's up, people? What's up? Long time no see. How are you guys doing? Oh my god. Just give me a second, guys. I'm not able to read your chats. How's it going, people? All good, all awesome. What's up? How is it going? Hello. All right. All good? Yes. Now I can see your chats. Arey, what's up there? What's up, people? How are you guys doing? Hi Soham, hi Vivek, hi Vishal, hi Prachi. Long time no see. I hope you guys are all doing awesome, doing excellent. Yes, having a good time. I hope your preparations are also doing good, going good, right? So yes, today we'll be doing the Sprintex series, session number 2 of electricity. So what we're gonna do is basically, for all those who are new to Sprintex, you do not know what exactly happens here. We basically try to do as many questions as possible within the given amount of time, right? So we'll try to do the questions as soon as possible. Now generally we'll be having a lot of questions, like we'll do about 10 to 11 questions, not more than that. What we'll try to do is basically we'll try to do the questions in the least amount of time possible, right? So that's what Sprintex series is all about, and that's exactly what we will try to replicate today as well. All right, so how's it going, people? Welcome to the session. For all those us trying to figure out where I'm sitting, I'm in Abhishek sir's house apparently, right? Because it's like I'm setting everything up right now. That is why. So, anyways, welcome. Let's begin today's session without wasting much time. Now, so in the last session of Sprintex, session number 1, that is, we did a couple of questions about current and potential difference and Ohm's law, resistance and factors affecting resistance in series as well as parallel, and it was really good to see such amazing response. I could see a lot of answers putting down, you put down the homework answers in the comment section below, so hats off for that, people. So this is the homework question that I had asked in the previous session. Today we'll be doing this, by the way. The question was this: what is an electric circuit, and distinguish between an open and a closed circuit? Now, if in case this question is ever asked in your boards, this is never going to exceed more than 2 marks. But for all those who are wondering what exactly is an electric circuit, like you're trying to figure out the answer for this, an electric circuit is basically nothing but a complete path for the current to flow, which consists of your bulbs and resistors and other electronic components, which basically forms a path for the current to flow through the circuit. That's what is an electric circuit. Now, the difference between an open and a closed circuit is that an open circuit is one where the current does not have a complete path, or you can say there's an incomplete path. Like, for example, when the switch is turned off, or if there's a disconnection, that is called as an open circuit. A closed circuit is one where the current has a complete path to flow. That means it is flowing from the positive to the negative terminal, and it's basically completing that whole circuit. So that was the answer. That was the answer for the homework question, for all those who got it right. Congratulations. So with that said, people, so today what we're going to do is basically do a lot of questions on heating effect of electric current, electric power, energy, and some of the numericals that goes along with it. And lastly, definitely not the least, commercial unit of energy as well, right? So with that said, let us begin. Give me a oh yeah in the chat box, people, if you guys are all ready. Unfortunately, did I not give access to edit this? Oh yes, I did I, or did I not? I don't know. Let's see. Can I write all right. So again, the Abhishek says this thing no is very weird. It's very yes, oh yeah, yes, all right, that's a spirit. Thank you. Oh, by the way, this is the Sprintex going on right now. So magnetic effects of electric current would be coming on 28th. The subsequent one would be coming on right after that, so it'll be on 4 p.m. every single days ahead. For biology, it'll be taken up by Maria ma'am. This is the schedule for that. You can always download the notes later and check it out for yourself. For chemistry, it'll be taken up by Shilpi ma'am, and these are all the different topics that will be covered in that sessions. Carbon and its compound, I believe it's already out. You'll have periodic classifications of elements coming up pretty soon. Then we have Shweta ma'am, who will be taking up English. The dates are right there. A lot of English, chapters in English, so there's going to be a lot of sessions of English as well. Math goes the same. Gopal sir would be taking it up. Lots of sessions of math, and you'll also have chemistry as well, taken up by none other than Ananya OP sir. You'll have a lot of sessions of social science as well, because you have a lot of chapters coming up in your term 2 examinations, right? So before we get started, do not forget to like, share, subscribe. Oh yeah, all right, so let's get started. So here's the thing, guys. We have divided this into 3 different sections. All right, section A is the 2 markers, section B would be the 3 markers, and section C would be the 5 mark questions. All right, so we'll keep it very short, very light. We'll do only the most important questions, so make sure you stay till the end, solve every single question, don't leave anything. Take your notebooks and pen because there'll be a lot of numericals today, so be ready for that and start doing the numericals along with me. I'll also help you out, but the Sprintix funda is this, people. For example, let's say there's a 2 mark question given to you. Now, in your examination, you can take up to 2 minutes to solve this question. But here, we'll try to do it in less than 1 minute. So that is basically the funda. So you have to be as quick as possible, as precise as possible. So make sure you have your pens and papers, everything ready. Don't use a calculator because in your examinations, you're not allowed to use a calculator. And keep that in your mind that your exams are starting another 1.5 months. So be very, very, increase your confidence level through this. All right, here's the first one. Why does the connecting rod of an electric heater not glow while the heating element does? Imagine a room heater, guys. Imagine a room heater. Now, the power plug that is there, right? That is connected to the switchboard. Now, why doesn't the power plug also glow? Why doesn't that also become red hot? Why is it only the element that is getting hot? Anyone? What do you think is the answer? Yes. Oh, is it? Oh, there's a code of Abhishek sir also. All right, Drona 1, Drona 2, you can check it out for yourself, people. I am really not sure. Again, thing is that I've moved to a new place, so I need to set everything up. For that reason, I have to borrow Abhishek sir's studio for a couple of days. Okay, all right, exactly, guys, exactly. The reason is very simple. The reason is very, very, very simple, guys. It's just that, see, it's the same amount of current flowing through both of them. Now, if you remember, guys, heat energy produced in a circuit is equal to I square RT. This is the formula. H is equal to I square RT. That means H is directly proportional to the square of the current flowing through it. H, that is heat, is directly proportional to the resistance, and heat is also directly proportional to the time for which the current is flowing through it. Now, current and time would remain the same. For however long the switch is turned on, that much amount of time the current will also be flowing through the element as well as the power plug as well. But the one major difference is that the connecting rod will have lesser resistance. It is made up of copper. Generally, the connecting wire is made up of copper, which has comparatively lesser resistance. It's a better conductor. But the element that we're talking about, right, the one that becomes red hot, that is actually made up of a material called as nichrome, or it's basically a alloy of nickel and chromium. That has much higher resistivity, or in other words, has a higher resistance. Since it has a higher resistance, there's more amount of heat produced in the connecting or in the element than the connecting rod. So this is the reason for it. So anytime you just think about it, current will be the same. It is connected to the same potential difference. It's connected to, it'll be running for the same amount of time. The only difference is that this element, the heating element, has much higher resistivity or has higher resistance. Because of it's producing a lot of heat, and that's why it's becoming red hot. Got it? That is the answer. Very simple question. Super duper easy. 2 marks to aaram se in your pockets. You don't have to think about that question after that. All right. Another question. Get another easy one. Simple substitution. Simple formula. Get the answer. 2 mark question once again. 2 minutes in your exams. Let's try to do it in less than 1 minute. The question is, an electric iron of resistance 20 ohms. All right. It's 20 ohms. 20 ohms takes a current of 5 amperes. Calculate the heat developed in 30 seconds. They've given you the resistance, they've given you the current, they've also given you the time taken. I don't think there's going to be a much more easier question than this. Just put on the answers, put on the values in the equation and get the answer. Super straightforward, super direct. You guys let me know what formula should I be using in this question first. Yeah. Is it? Are awesome, Soji? Are awesome, that's so awesome. So because okay, it's not that boomit. That's what. It's not that the flow of current is different in either of them because they're both connected in series. The only difference with the previous one is that resistance is different, right? Exactly, guys. The simple formula that you have to use, because you have to find out the heat generated here. The formula is what? You have to use Joule's law of heating. H is equal to I square RT. Substitute the values over here. I is nothing but 5 square. Resistance is nothing but 20. Arre. Wait. Where is the eraser? Oh, eraser. Oh my god. Abhishek sir's, writing pad, no, is exactly like Abhishek sir. It's like Teda. It's full on Teda. It's like, there's this ad that comes up in, have you ever watched this Kurkure wala ad? Teda hai par mera hai. It's exactly like that. I don't know, like if I were to touch in one corner, the pen, the cursor goes to another corner. It's exactly like him. It's exactly like his brains only. All right. So, anyways, it's hopefully he doesn't hear all of this and then come beat me up later. Okay, anyways. Look at that. I'm writing all over it. Okay. Wait, let me just try to figure out how to write this. Okay, into 20 into 30. Yes. Just substitute the values over here. That's 25 into 20 into 30, which when you multiply, you'll get it as 15,000 joules. So the answer is 15,000 joules. That's the answer. He is complete data now. That is completely data. Alright, so anyways, the answer for this question is 50,000 joules, guys. That's it. As simple as that. Substitute, get the answer, and you're good to go. That's all. I don't know. I don't know if he's using. I don't know which version of PowerPoint he's using. I think it's like, it was this version of PowerPoint was installed in the 1980s, before computers were even there. Abhishek sir had installed PowerPoint. Getting it? Abhishek sir is too fast. Before even computers were discovered. Before Alan Turing came up with the whole concept of computers, Abhishek sir had installed Microsoft PowerPoint. That's how fast Abhishek sir is. Alright. Yet another 2-hour question, guys. Yet another 2-hour question. Yeah, apparently I am. Alright. So anyways, another 2-hour question. 2 minutes time. We'll try to do it in less than one. Once again, it's a numerical. Simple numerical. Straightforward answer. All you have to do is figure out what is given, substitute or think about what formula you have to use here and get the answer. The question is, an electric heater of resistance 8 ohms draws 15 amperes from the service mains for 2 hours. Calculate the rate at which heat is developed in the heater. Okay. All right. Now, I'll write on the given data first. Just pay attention, people, because this is a very important question, and it's actually not that straightforward as you think it might be. Let me just tell you why. So resistance R is given as 8 ohms. All right. Current is given as 15 amperes. All right. Time taken is given as 2 hours. So we'll just convert that to seconds. So that's basically 2 into 60 into 60. 1 hour is 60 minutes and 1 minute is 60 seconds. So 3,600 in total. Whatever you get, just keep that as it is. Right. Now, thing is, guys, you have to calculate the rate at which heat is developed. What do they mean by this? When they talk, exactly, guys, exactly. When they are talking about rate at which heat is transferred or heat is developed, they are talking about power here. They are not talking about heat energy. The rate of doing work is what is called as power. If you remember, we had learned this in the regular sessions. That is, in the Umang session, that the heat energy developed is equal to the work done by the battery, and this work done is equal to energy gained by the charges. It's all exactly the same. Now, rate of doing work is what is called as power. Here, it's basically what? The rate of heat transfer or heat developed, that is also nothing but power itself. It's all equivalent. So all you have to do is find out the power here. You know the current, you know the resistance, you also know the time taken as well. You can easily find out the power. In fact, to find out the power, you don't need the time taken, because we know that power is equal to I square R. We can just directly substitute this formula. How did we arrive at this formula? If you remember, P is equal to V into I. So substitute the values and you'll get the answer. All right. My handwriting, first of all, I have a very horrible handwriting. On top of this, I don't know what Jadoo Abhishek sir has done. Not able to write anything on this. All right, 15 square into 8, substitute the value. How much will you get? How much is the answer, people? 1800 watts, right? 1800 watts would be the answer. So that's pretty much it. 800 words would be the answer. So you don't see this whole thing about time taken. No, it's just a distraction. You don't need to find this out. Honestly speaking, you don't even need to find it out because they've not asked for it. They're not asking for the heat energy generated. They're asking for the rate or at which heat is generated, which is nothing but power. All right, sounds good, people. Easy question, but yes, anytime you see this particular word, rate at which heat or rate at which energy is transferred, all of that means it's nothing but power itself. So keep that in your mind. In mathematics also, there are few things that you remember. No, in the question there are few keywords that you remember and you do it according to that. So here also it's the exact same thing. Do not forget that. All right. Okay. So that marks the end of the 2-mark questions. Now let's go on to the 3-mark questions. Same funda. 3-mark question is going to be a little bit more longer with a little bit more calculation. Maybe the question might be divided into 2 or 3 parts. But 3 minutes in your examination. You can take up to 3 minutes time in your exams. We will try to do it in less than 1 minute. Forget about 2 minutes. 2 minutes is for kids. We are pros now. My exams coming, 1.5 months left. We've all become experts. So we'll try to do it in less than 1 minute. 2 minutes is for kids. 1 minute is for men and women. So we'll try to do it in less than 1 minute. What do you guys say? Huh? Challenge accepted, people? Can you do this? What do you think? 1 minute. Around we can do this, no? All these silly questions alone, 1 minute is like too much, right, sir? I know, right? Too much time, no? Exactly. Let's try to do it. Okay, so 5th question, people. I know. I'm sorry. Calculate the effective resistance. That's the first part of the question. Calculate the effective resistance, which is very straightforward. Calculate the current flowing through it as well. Again, very simple. And also calculate the potential difference across the 10 ohm resistor as shown in the figure. So very simple. The first 2 sub questions are so very straightforward, very direct. Aram se you can do this. Okay, tell me first thing, people. This 5 ohm resistor and 10 ohm resistor, are they connected in series or are they connected in parallel? First question. Are they connected in series or are they connected in parallel? That is the first thing you need to figure out. Series, absolutely. In series connection, we know that. Okay, let me just put it on the table now. I've had enough with my amazing handwriting. Let me just put it over here and see if I can write it now. Where was I? Effective resistance. R equivalent is equal to. It's not getting any better. Why is it all teda? That's what I don't understand. Why is it all left? Okay, 1 sec, guys. 1 sec. Is that nah? 1 sec. Okay. Jesus Christ. Okay, all right. It's all, even though I'm trying to write as straight as possible, it's still, okay, wait. R1 plus R2 is what you have to write. So R1 here is nothing but 5 and there's nothing but 10. So the effective resistance or the equivalent resistance is nothing but 15 ohms. That is basically the effective resistance or equivalent resistance. Effective, equivalent, it's basically the same thing. All right, don't get confused. Okay. What is the current flowing through it? It is connected to a 2-volt battery. Total resistance is 15 ohms. So what will be the current? Current is equal to V by R. Simple. So what is V here? V is nothing but 2. Resistance is nothing but 15. So how much is 2 by 15, people? 2 by 15 is how much? You'll get it as 0.113. 2 by 15, okay, you want to keep it as 2 by 15, keep it as it is. Or if you want to convert it to decimals, you can do that. You'll get it as 0.3133, something like that. 0.133 amperes is what you're going to get. If you want to keep it as decimals, keep it as it is. Or you can also convert it to, fraction, keep it as it is. Or if you want to convert it to decimals, that's also absolutely fine. The last part of the question is find out the potential difference across a 10 ohm resistor. Very simple again. We have to use Ohm's law over here. V is equal to I into R. Since it is connected in series, current will remain exactly the same. We know that. We have studied that a billion times. So current is 2 by 15. Resistance is 10 ohms. How much will that be? It's nothing but 20 by 15. So you'll get it as how much? 1.33, something like that is what you're going to get. So 1.33 volts would be the potential difference across the 10 ohm resistor. So if I have to write it over here, okay, 1 second. I can't even see the pointer anymore. 1 sec. This across this, it'll be 1.33 volts. That's the answer. Got it? Super simple, super duper easy question. You can simplify this even further if you want to basically divide this by 3. So 5, 3, 15, 5, 4, 20. So 4 by 3, again you'll get is 1.33 volts itself. That's the answer. All right, super duper easy. Again, 3-mark question. I don't see, again, to explain it I might require a little bit more time. But if you have to really solve it, I don't think you actually need 3 minutes or 2 minutes to solve this. You can easily, very easily do this question in just a couple of seconds. So again, try to improve your time as much as possible so that it gets more and more easier and you get more comfortable with the subject. All right. Sixth question, again a 3 marker, 3 minutes time. We'll try to do it in less than one. The question is, compare the power used in a 2 ohm resistor in each of the following circuits. At first, a 6-volt battery is connected in series with 1 ohm and 2 ohm resistor. And in the second one, you have a 4-volt battery connected in parallel with a 12 ohm and a 2 ohm resistor. You need to find the power, compare the power used in the 2 ohm resistor in each of the following circuits. So you have one 2 ohm resistor connected in series to a 1 volt, 1 ohm resistor, which is connected to a 6-volt battery. Another one is connected, the same 2 ohm resistor is now connected to a 12 ohm resistor, but then this time it's connected in series. You need to find out compare the power used in both the cases. So let's start with the first one. All right. Okay. Now tell me, guys. First of all, which formula of power would you be using here? Which formula of power would you be using in this particular scenario with all the given information? Which is the best possible formula of power would you that makes sense to be used in this equation? V square by R? Sure, Nipun? Okay, let me tell you one thing. Let me just ask you one question. Since these both are connected in series, what would remain constant? The current would remain constant or the voltage remains constant? Think about it. Current remains constant or voltage remains constant? Sure, V square by R. Pakka. Pakka. Current remains constant. So I would, if I were to do this question, I would first find out the total resistance, then find out the current flowing through it so that I can use the formula P is equal to I square R, because, sorry, I square into R. My God. 1 second. Wait. Y square into R. I square into R. Just use that because you don't have to individually find out what is the voltage across 2 ohm resistor. You can directly use the, because it's a series connection, so current will anyways remain constant. So first of all, find the current flowing through it. What is the current flowing through it? Current is equal to V by R. Voltage is 6 volt. Resistance, see, both, there are two resistors when they're connected in series. When they're connected in series, R equivalent is equal to 1 plus 2, which is equal to 3 ohms, right? So substitute that over here, it's equal to 3, which is what? It's nothing but 2 amperes. So the total current flowing through the 2 ohm resistor is nothing but 2 amperes. And on top of that, it is basically, what to say, you have to find out the power on this. So just find out the power. P is equal to I square R. So what is the answer? It's going to be 2 square into resistance is what? Resistance is nothing but, it's a 2 ohm resistor. So it's going to be 2 into 2 into 2 into 2, or 2 into 2 into 2, which is what? 2 to 4, 4 to 8. So it's going to be 8 watts. All right. I hope it's, yeah, simple, right? So you'll get it as 8 watt. Now, if we talk about the second one, in the second one, they're connected in parallel. So find, you see, thing is that in parallel connection, we know that the voltage remains constant, right? In parallel connection, voltage remains constant. So if I were to talk about the parallel connection here, what would be the, see, if you want, you can actually, okay, we'll do one thing, we'll find out the current over here also. So this is the voltage, this is basically 12 ohms, this is 2 ohms. So find out the current, what is the current flowing through the 2 ohm resistor? Let's try to find that out. So if you look at this one, my God, my handwriting has become so hopeless. I'm not able to control this only. So like, it was a bad idea taking the session over here, I feel. All right, it's 2 ohm resistor. The voltage across this is 4 ohms, because, so 4 volts, because it's connected to a 4 volt battery, so voltage would remain exactly the same. So what's the current flowing through it? So I is equal to V by R, which is equal to what? 4 by 2, which is equal to 2 amperes. 2 amperes is the current flowing through this one as well. Now use the formula once again, P is equal to I square R. So it's going to be 2 square into 2 again. So how much is that? Again, you'll get it as 8 watt itself. So if you were to compare both of them, if you talk about the comparison of power, so we'll take this as P1 and we'll take this as P2. We'll take this as P1 and we'll take this as P2. So P1 by P2 is what? 1:1, right? P1 by P2 is equal to 8 by 8, which is equal to 1:1. Yes. Oh my God. This thing, no, is like, Yeah, I'll use. I think this is a better colored. To write on this is so hard. People, you have no idea. It's like so slippery. God knows for how long he's been using this pad. I'm so frustrated with this pad right now. All right, unfortunately, guys, don't follow this one. They've given the wrong answer over here. The thing is that no, what they took it as one more 2 ohm resistor being connected in series with the first two resistors of 1 ohm and 2 ohm, and in the second one again they took another 2 ohm resistor being connected in parallel with 12 ohm 2 ohm resistor. That is not the question. Is they've actually given the wrong answer here, but the question is compare the power used in the 2 ohm resistor. They have not mentioned that there is another 2 ohm resistor along with 1 ohm and 2 ohm which is connected in series. So please don't go by this. The answer given over there is clearly wrong, so don't go by that. All right, okay, seventh question. Let's go. 3 markers. Again, a 3 mark question. 3 minutes. We'll try to do it in less than one. The question is, a fuse wire melts at 5 amperes. If it is desired that the fuse wire of the same material melts at 10 amperes, then what should be the new fuse wire? Then should the new fuse wire be smaller, or should it have a larger radius than the earlier one? And give reason for your answer. Let me repeat the question one more time, guys. You have a fuse wire which has a power rating of a current rating of 5 amperes. Now your intention is to increase from 5 amperes to 10 amperes. But here's the thing, you're going to use the same exact material. You're not changing the material. That means resistivity remains exactly the same. Now the question is, what should you do about the new fuse wire? Should you make the diameter or the radius a little smaller, or should you make it larger in order for it to have a power rating or current rating of 10 amperes? What do you think, people? Should you make it smaller or larger? Hi Charan, what's up? Akias are getting married. Akias has already gotten married. Soon he's gonna have a little kid also. What are you talking about? Alright, exactly. You're gonna make it larger. Exactly, people. Exactly. That is the only thing. See, the thing is very simple. We know that resistance. See, resistance is directly inversely proportional to current. Right? You need more current here. You need more current. If you want more current, you need lesser resistance. Resistance we know is nothing but is equal to rho into L by A. Now here the resistivity and length is remaining the same. We are not changing the resistivity or the length. So R is inversely proportional to area, which means that if I were to increase the area, that is by increasing the radius, because we know that A is equal to a pi r square. So if I increase the radius, area will increase. So more the area, lesser would be the resistance. Now, the thing is, people, it's a 3 mark question, so you can't just write down the formula and expect to get full marks. You need to do a little bit of explanation as well. So explanation part, though, you can write something like this. This makes a little bit more sense. So you can write down the complete detail. Write down that heat produces, is equal to I square RT. And you can mention that resistance is directly proportional to heat. So in order to reduce the resistance, you need a larger cross-sectional area, because we know that more the radius, more the cross-sectional area, and more the cross-sectional area, the lesser number of collisions would happen. That is lesser resistance, and hence that would actually help you to increase the current rating from 5 amperes to 10 amperes. Got it? Clear, people? So that is the answer for that question. Moving on to the 8th question, people. We are almost towards the end. We are almost done. Another couple of questions and we are done. So the 8th question is again a 3-mark question, people. Again, 3 marks, 3 minutes time in your exams. Less than 2 minutes, we'll try to do it. This is going to be very simple, straightforward. The question is, two resistors of resistance R and 2R are connected in parallel in an electric circuit. Calculate the ratio of the electric power consumed by R and 2R. Now, how would you approach this? Come on, guys. Let's go. Yeah, Vantika, I am. And yes, why is it so hard for you guys to believe that Abhishek sir is married? What do you think? Like, what did you guys think? That he's going to be a sannyasi forever or what? Huh? Does he look like he's a sannyasi? Do you think Abhishek sir, does he look like a sannyasi to you guys? Huh? I think he was gonna wear what is that? Khadi dress and yellow color, this thing and all, wear some mala and everything and walk around. You think what did you expect Abhishek sir to do? He's a normal human being. He was bound to get married one day or another. Why is it so hard for you to believe? I still get questions. It's been almost 2 months now, and I still get questions. That's why I'm still asking. I'm just wondering, like, what is so hard to believe? Exactly. Abhishek sir and Brahmachari. Oh my god, nice joke. I like it. All right, so let me just finish it off now. How do you do this? You have to find out the ratio of power consumed. So we know that, guys, see, they're both connected in parallel. So we know that in parallel voltage remains constant. So we know that P is equal to V square by R is the one that makes sense because they're connected in parallel. So voltage would remain exactly the same. So P1 is equal to V square by R. P2 is equal to V square by 2R. So you need to find out the ratio of the power consumed, R by 2R. So P1 by P2 is equal to V square by R whole divided by V square by 2R. V square by 2R. So here V square gets cancelled. So this is going to be what? Going to be 1 by R whole divided by 1 by 2R. So 2R will go to the numerator, this will come to the denominator, so it will become 2R by R. R gets cancelled, so it is 2 by 1 or 2 is to 1. That's the answer. Alright, but if you look at the answer given over here, I don't know where they got this from. I have no idea. Apparently, out of nowhere, they pulled out resistance as 8 ohms. They took the current as 15 amperes and they got the heat developed also as 1800 watts. I don't know how they got it. And that too, 1800 watts, they got, okay, the rate of heat developed, they got it as. Please don't follow the answers. Don't follow the answers, guys. I don't know from where they got this, but please don't go with the answers. Just follow this one. I know the handwriting is very legible and very clean, but try your best to figure it out. All right. Okay. Use Google Translate if you have to. Moving on to the ninth question. Almost towards the end, guys. Almost towards the end. We're almost done. That's it. Here is another question. All right. 3 mark question again, 3 minutes, less than 2 minutes, we'll try to do it. The question is, which uses more power? A 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes? Which of these uses more amount of power is the question. Let's go, people. Hi Bhargavi, Arey, what's up? How are you doing? No, I haven't sealed Abhishek sir's house at all. He's probably listening to the conversations and he's probably scolding in his mind right now. Telling himself like, why did I have to give this guy my room for today? He might be scolding in his mind like, why did I choose this? Why did I say okay to let him borrow my studio? He might be scolding in his mind right now. After I go out, he's gonna beat me up. We have left, right, center. Both of them together are gonna gang up on me and beat me up. I know. Oh my god. Alright, Abhishek sir. I broke another stuff. Alright, yeah guys, let's go. Jesus Christ, I broke his phone holder. He's gonna kill me now for sure. Today I'm so dead. Alright, so how do you answer this question? Very simple, guys. Very simple. Which uses more power? Okay, so how do you do this? So power is equal to power. You have to find out the energy, right? So power is equal to energy by time. So energy is equal to what? Energy is equal to power into time. Simple. So for the first one, that is the TV. We'll take it as ETV is equal to P into T, which is equal to power is what, 250 into time is 1 hour. So it's running from 1 hour, which means convert that to seconds. So 1 hour into 3600 or 1 hour into 60 minutes and 1 into 60 seconds again. So that's going to be basically, how much is that going to give you? That is going to give you around, I believe 93,000 something or 93 or how much is it going to, like 250 into 1 into 60 into 60 is how much, huh? Or if you want to convert, keep it as hours, that's also fine. But here they've given it in terms of minute. So yeah, you can do one thing, guys. You don't have to do 60 into 60. You can just do it as 16. Okay, if you want to do that, that is also fine. But it's not exactly the SI unit. But yeah, I think it'll be better if you keep it as joules, so that they don't cut marks for that as well. So 250 into 60 into 60, that is 250 into 3,600. You'll get it as 99 lakh something, I think. Or is it 93,000? I think it's 9,30,000. 9,30,000 is what you're gonna get. 9,30,000 joules is basically the heat generated by the energy used by the TV. Now to talk about the toaster, it's basically going to be the same part. Toaster is equal to it's exactly the same thing. So energy is equal to power into time. The power here is 1,200 watts and time taken is basically 10 minutes. So convert that to seconds. So basically into 60, that's basically 600 seconds. That is, so into 60, that's 1,200 into 1,200 into 600. That is going to be around 7,20,000 joules if I'm not wrong. 7,20,000 joules. So the answer to this question is the TV. The TV is the one, even though it has lesser power rating compared to the what is it called as to the toaster, it's still turn on for a really long time, and hence for that reason that is actually consuming more power than that of the toaster. All right. So that's the answer, guys. That is the answer for this question. I hope it's clear, people. Exactly, the TV uses more energy here. All right. So that is the answer for this question. So simple, straightforward, done and dusted. I don't know. Again, over here also they've used, they've kept it as watt hour itself, and they got it as 250 watt hour, and here they've converted to hours again. So 10 by 60, they got it as 200 watt hour. So again, so obviously the TV is using more power over here. All right. Okay, guys. That marks the end of 3-mark questions. How many of you guys got all the questions right? We've done 9 questions so far. How many of you got all 9 questions right? Like super awesome. I know it. Why am I here? I'm here to mess up his place. No, it looks so clean. Everything's so white and stuff. Everything's so white. I don't like things which are white. I want to make it dirty. Wait. Yeah, all correct. All correct. Are awesome, Dawadyaj. Is there anyone else who has gotten all the questions right? Or so you realize, no, unfortunately, not. Unfortunately not. Because he's using a desktop. That's the problem. Abhishek sir uses a desktop. If I want to carry the desktop, I have to carry the whole thing. Not possible. That's why. Otherwise, I would have. Done, Bhargav. Awesome, 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 awesome. All right, so people, let's go on to the last question, which is basically a 5-marker. We'll just end it with this. This is the last question. It's a 5-mark question. Straightforward, very simple. So a 5-mark question generally should take about 4 minutes to solve it, 4 to 5 minutes. Definitely not more than that. I know it's a lot of marks, but still, it's really not, it just really doesn't take a lot of time. And on top of that, we'll try to do it in less than 2 to 3 minutes. All right, so here's the question. A household uses the following electric appliances. The first one is basically a refrigerator, which has a power rating of 400 watts, which is run for 10 hours every day. 2 electric fans of rating 8 watts, each run for 12 hours each day. Another one is basically an electric tube of power rating 18 watts, and it's run for 6 hours every day. Calculate the electricity bill of the household for the month of June if the cost per unit of electric energy is 3 rupees. Amazing question, amazing question. So first thing first, people, find out the energy consumed by the refrigerator, by the fan and the electric tube, because you need to find out the cost, right? And in order for you to find out the cost, you need to basically know the energy consumed, right? And how do you find out the energy consumed here? Energy is equal to power into time. So basically use that formula. For the first one, for the refrigerator, energy is equal to power into time, which is basically how much? It's 400 watts. It's run for 10 hours every day. So into 10, so that's basically 4,000 watts. Now for the electric fans, there are 2 electric fans, each of 8 watts. I think it's 80, but I don't know why they've written as 8. I think it's 80 for some reason. Why would you have a power rating of 8 watts? 8 watt though, you'll get a bulb. I think it's 80, people. I think it's better if you keep it as 80 watt for now. We'll just keep it as 80, I guess. I think 80 is better. Keep it as 80, guys. It's not 8 because 8 is way too less. I think they've missed out the 0, because we invented 0 and sometimes we end up forgetting it. One sec, guys. I'm not able to see any of your chats. Just give me a second. Just give me 1 second, guys. I'm not able to see any of your chats. Okay, apparently I've gone offline. Oh, 1 sec, guys. 1 sec. I'm not able to see any of your chats. 1 sec. 1 sec, people. 1 sec. I think Abhishek sir is using a blocker now. He's trying to mess with me there. Right. Okay, I'm not able to wait. I don't know what is Abhishek's Wi-Fi password also. Just give me 1 second, people. I'm not able to see any of your chats. Right. What's his password? Just give me a second, people. I'll try to. My internet is not working. Give me a second. God. Why? Why you do this? My internet is not working. There. Just give me a second. I was using my mobile internet all this while and now it's not working. Just give me 1 second, people. Wait. Let me try to change some. Oh, yes. Thank you. Thank you, Airtel Ji. Thank you. Much appreciated. Just give me a second. It's a whole mess. I'm just waiting to set up my this thing first. All right, I think you guys okay. Now it's fine, no? Yes. Thank you, thank you, thank you. All good. All right. Okay, now we will. So I think it's better if you take it as 80 watt because again 8 is little too less. So we'll just take it as 80 for now. So 80 watt. You have two of these, two fans of 80 watt each, and it's run for 12 hours every day. So how much was that, people? 80 into 12 into 24, or 80 into 24 is how much? Quickly done the chat box. Avizar is not Batman, he's Badman. He's not Batman, he's Badman. Like Badman. Oh yeah, tell me. So what is it? 80 into 12 into 2 is, I think it's around 920 watts if I'm not wrong. Please correct me if I'm wrong. And last but not the least is the 18 watt tube. So 18 watt, you have 6 of those. If I'm not, no, it's run for 6 hours. You have 6 of those. So into 6, you will get it as somewhere. How much will you get this as? Right. So you'll get this around 648, something like that. 680 or 48 watts is what you can get. So the total energy consumed is equal to 4,000 plus 1,920 plus 648 plus 648. Array, this thing, no, this pen is like, oh my god. If it was my pen right now, no, honestly, I would have just broken this. Honestly, I would have just broken this thing. 648. How much is that? You'll get it as around 6,568 watt is what you're gonna get. Then this is watt hour. All right, all of this is in terms of hours. So convert this to kilowatt hour. Divide this by 1,000. So you'll get it as 6.568 if I'm not wrong. 6.568 kilowatt hour is what you're gonna get. This now multiply. So the thing is that, guys, this was per day. Per day, this is the energy consumed. You have to calculate for the whole month of June, which is nothing but 30 days. So the whole month of June, it is going to be 6.568 into 30, which will give you as 197.04 kilowatt hour. This now multiply with the cost. So if you want to find out the cost, it's going to be 197.04 into 3 rupees, which you'll get as 591.12 rupees. So that's the answer, guys. Lot of calculation, but yeah, simple, straightforward, and you're done. So that is the end of the Sprintex series, guys. That's all for today. Again, sorry for my beautiful handwriting and stuff. It's just that I haven't set my place yet. So with brand new background and everything, lots of things are in store. So that's it for today, people. I think we'll call it a day for now. That's all for today. That's the end of the Sprintex electricity chapter. But yes, we've done a lot of sessions for this already. Sprintex is one. We also did the top 20 questions of electricity. We've done 2 sessions of that. So 40 questions in total of that. And then 10 questions each of Sprintex. So that's about 60 questions in total we have done from electricity alone. And we've done the same for magnetism as well. Magnetism will be coming. The videos will be coming out next week from Tuesday. Monday and Tuesday will be coming out. So I'll catch you guys then. Until the next time we meet, take care of yourselves. And yes, I will say that I'll definitely ask Abhishek sir for his permission, but I'm pretty sure I'm only going to get slapped and he's never going to do that. But yes, just kidding. Abhishek sir doesn't slap me, you know. Abhishek sir doesn't. Abhishek sir only hits me. Yes, Abhishek sir doesn't slap me, you know. So yes, that's it for today. I'll catch you guys in the next one. Do not forget to like, share, subscribe. I'll catch you guys in the next one. Until the next time we meet, this is Anoop signing off for the day. Take care of yourselves and bye-bye for now. Take care, guys. Bye-bye. See you all. Oh, sure, sure. Yeah, yeah, definitely. Biopracticals. Even biopracticals, huh?